set? Okay, so we're with my favorite class this morning, class 651, and no, it's 633. And so I'm going to be talking about the lab we're starting today, January 6th, I believe it is. And this is a conduction lab. So what we have in front of us, going to be giving the students 2 styrofoam cups, 2 foam lids, 2 thermometers, and an aluminum conduction bar. And what the point of the exercise is to see how well or how not so well, how effectively or how ineffectively energy can. Georgie, can we just cool it just for like 2 seconds? So whenever I make these videos, you would think your parents are going to watch them, and you'd think, let me just make sure that they don't hear my name mentioned within the video. Honestly, if I was going to be on, like in a movie, and my teacher was filming it, and my mother's, Georgie, is your mom going to watch this? Definitely. Yeah, probably. And she's going to say, that's the first name I hear is your name. Why do you? Okay, so let's move past that. Okay, so we're going to have this set up like this. And the 2 cups are going to be set up in this direction so that we are able to facilitate heat transfer from one to the other. Now, this is not hot water. Girls? Now, typically, girls are smarter than boys. But some girls in this class are out to prove me wrong, and they are effectively doing so. Okay, so in the red cup, we're going to put some hot water, and in the blue cup, we're going to put some cold water. So we're pretending that these are different temperatures. And then we're going to set this in, and we are going to watch to see how energy in the form of heat is transferred from one cup to the other. So far, so good. I'm sorry, girls, am I interrupting? I hate to interrupt girls when they're talking because they're just so animated. So what did we say are some of the things that we could change in order to speed up or slow down heat transfer in the cup? Max?
You could put the bar lower down.
Okay, so you could raise up the bar or lower it down to make sure it's coming in more or less contact with the water. What else could we do? Seriously, we just did this. I'm filming because we just went over these things, and I figured this is a good time to do it.
Change the amount of water in the cup.
We could use a different amount of water in the cup. Anybody else? Yes, Georgie. He's going to redeem himself now.
You could wrap paper towels around it.
We could put some kind of an insulator around here. Anything else?
We could change the height of the bar.
I believe we said we're going to change the height of the bar.
Sorry, my bad.
That's okay. My bad what? My bad. Anyway. Anybody else? What else could we do? Okay, so listen to me carefully, which we have not gone over yet, but I want to see what you know as far as doing these labs to impress this on your parents to show that you're really working hard. How would we start out the wording of the hypothesis? Think for a second. Because this is all we're going to be doing this year is figuring out how to write a hypothesis and do the lab based on that hypothesis. Yes?
If we do this.
If we what?
If we do this.
If we do what? If
we raise
how about if we don't use a pronoun? So if
1, 2, and 3 milliliters were combined in,
we'll call this a conduction setup.
an A and B conduction setup, then conduction B will have a higher temperature due to
Whatever.
yeah.
Okay. Anybody else? Yes.
If we add more insulators around the bar that's conducting heat, then the temperature of the cold water will be affected.
Okay, so if we increase the layer of conductor surrounding the conduction bar in a conduction setup, then so we've been using for the chemical reactions, we've been calling them chemical reaction C is greater than chemical reaction B. What would we use for this? What terminology would we use? Girls, we're on a roll this morning. I know. It's bright. I know it's early. no more coffee before you come to school. When you go to, they tell them decaf in the deli.
Wow, it seems like I really need
I
coffee
know.
because
Yeah,
my
nobody
dad
really
woke
needs
me
it.
up early.
Yeah. Really? Okay.
Well, earlier than normal.
Oh, okay. So what are we gonna? We're not gonna say the reaction. What are we gonna say?
Cup A, cup A.
What about cup A? What about cup B? What about cup C?
We're gonna maybe say like insulator A and insulator B.
Cup C.
Say it again.
Like insulator A.
Look, see. Now he's on film. Now he's redeeming himself. So quiet. Say it louder, George. I can't hear you.
Insulator A and insulator B.
Okay, so yeah, so we could say that insulator A is greater than B, but how would we tell if the insulator is greater?
By the temperature?
Temperature of cup A, temperature of cup B, temperature of cup C. Okay, so we haven't discussed this either, but this will be good to have on tape anyway. We are not going to be able to run three different levels with this. Everybody in the room is going to get a different temperature water, okay? So what we're going to be doing, and I want to have this on film, am I crooked? I want to make sure my head is not
so are you
tilted.
saying that everyone will be putting the results into a
That's
data
exactly right, Jonathan. So we're going to be collecting all the data, and we're going to be using it. So we will be using different temperatures in the hot water. Okay. So what I want you to know that. So when you write this up,
So that means everyone would have to have the same problem.
everybody does have the same problem, and everybody should have the same hypothesis.
Okay.
Okay. Sound good? Okay, parents, if you have any questions, feel free to contact me. Girls? No, seriously. Oh, parents, I wish we had like some surround sound video here so you can see everything that's going on. But it's bad enough that I see it, so. Okay, anything else? Any questions? Georgie,
Smack that like button.
what do you say?
Smack that like button.
Oh boy, okay. Parents, you have a good day. Okay,
Subscribe to Michael L.
Subscribe to Michael Bobby.
shut it off.